Hey guys, so welcome to week 4, not quite sure what this is, of your distance learning. Today we're going to be doing sedimentary rocks. We're going to start them. This should be relatively short, so I might be able to get through the whole thing in one video. Don't know, we'll see by the end of the video. Just a quick heads up, you do have a test this Wednesday. It'll be on minerals, igneous rocks, and sedimentary rocks. That's guaranteed to be on your test. That's Wednesday. I'm going to say this so that everybody hears it. The test will be between 9 a.m. and 3 p.m. on Wednesday. If you do not take the test between those hours, do not email me. Do not tell me you woke up late. Some of you are emailing me and telling me, oh, you just woke up or you forgot to do it. No. You had your first week to get used to that. You had your second week to get used to that. And in third quarter, we are not taking that anymore. If you miss it, it goes in as a 0 and it will stay as a 0. Now, if you're genuinely sick or there's genuinely an issue, you need to report that to the dean's office, the attendance office. They'll give me notification that there was actually something going on, and then you and I can work something out. But short of that, you oversleeping is not an excuse. You will get a 0 and it will get averaged in as a 0. All right, so today's going to be sedimentary rocks, how they form, different classifications, and we're going to go look at them. So please make sure that you're paying attention to this, and we'll see you in the video. All right, guys, talk to you later. Bye. All right, guys, so when we talk about the formation of sedimentary rocks, there's 3 terms that I want to talk about. Those terms are deposition, compaction, and cementation. They're on the board right now. Please make sure you write them down in your notes. Make sure that you have a little space left after them so that you can fill in the definitions. Now, before we even actually talk about these 3 terms, we got to talk about something we talked about in the rock cycle picture. Before you can get a sedimentary rock, you need sediments, and we talked about sediments. What are sediments? Sediments are pieces of pre-existing rock or pre-existing material, little shards, little pieces. How do you get those things? You get those things through the process of weathering and erosion. Now, we will do a whole unit about weathering and erosion, but quickly, weathering is when you break something down that already exists, and then erosion is when you carry those pieces away. So that's what you see in the top of this picture, the weathering and erosion. Now, once you have those pieces made and they get carried away, eventually they get carried to a point where they can't get carried anymore and they get dropped off. When they get dropped off, that process is called deposition. Deposition is the process by which you drop off the sediments. So it's the laying down of the sediment. So you drop off the bits of sand, the pebbles, the silt, the clay, whatever it is that you have, you drop it off. Now, this process doesn't happen once. It keeps happening over and over and over again. As this happens, new stuff gets dropped on top of the stuff that got dropped off yesterday. The day after that, more stuff is going to get dropped off. And so what ends up happening is layer upon layer upon layer of sediment builds up. Now, this is similar to if you think of like the hamper in your bedroom. You throw your clothes in from Monday, it's on the bottom. Then Tuesday, you throw more clothes in. Wednesday. And what ends up happening is it ends up getting pushed down. The stuff at the bottom gets smushed together. While it was big and fluffy when you first put it in there, as time starts to go on, the space between the particles or the space between your clothes gets less and less. That's compaction. It's squishing. The layers on the bottom get squished by the weight of the layers on top. So this is what happens with a sedimentary rock. The stuff that gets deposited first gets compacted by the stuff that gets deposited second and third. Now, slowly over time, as you start to push these things down, what can happen is water or other substances can kind of fill in the little gaps, the pores between the sediments, and leave material. This material can act like a natural cement, a glue, which causes these sediments to stick together. This is what we call cementation. Okay, so you get these natural cements that start to stick the particles together, and you go from a loose collection of particles that's just kind of smushed together to stuff that's actually stuck together. Now, the pushing, the compaction will do a certain part of this, but the cementation is really what turns it from loose sediment into an actual sedimentary rock. All right, so when we talk about the types of sedimentary rocks, there's 3 main types, and then there's always, textures like we talked about before. Your 3 main types basically have to do with how the sedimentary rock formed, where did the pieces come from. So we have what we call clastic sedimentary rocks. Okay, we have chemical sedimentary rocks, and we have bioclastic sedimentary rocks. Okay, now the clastic rocks are usually what we call inorganic land sediments. Okay, and then the chemical or biological ones are exactly that. They come from either a chemical or a living creature. Now, if you look at the reference table right across from the page on igneous rocks, you will see this chart. Okay, and on this chart, we explain those different groupings. All right, so here we have that chart I was just mentioning. So if you look right here, you have your inorganic land-derived sedimentary rocks. So if you want to put right here, this is what we mean by a clastic. This group on top is what we would refer to as the clastic. You see the term right here, okay? So these would all be your clastic rocks, okay? They're fragmental. What that means is that they're pieces of something, fragments. And you notice there's different sizes here, right? That's going to be important for this chart. Grain size, just like we talk about crystal size with igneous rocks, grain size is going to be important. So it actually gives you these numbers. You may get asked questions that have to do with particles in these ranges. You have to pay attention to it. Composition is going to be, you know, kind of jumbled. Since you're coming from a pre-existing rock, you could be just about anything on this. Now, since most rocks have silica in it, it makes sense that they're mostly quartz, okay? But there are exceptions, okay? And then we have the comments, and this is what you want to look for when we're doing identifications. Now, we'll be back to these guys later, okay? And then you have the different rock names here. It also continues, obviously, down at the bottom here. You have the rock names here, and then something unique that we didn't see in the igneous rock, which is this symbol over here. These map symbols. As you do Regents questions, you're going to get maps that have these different symbols on it. You have to be able to identify the fact that if it's this symbol over here, we're talking about this rock. This symbol is this rock, this, etc., all the way down to the bottom of the chart. You have to pay attention to these map symbols. They're not just thrown in here for extra or, you know, to waste your time. They're actually going to be used on questions. If we look down at the bottom here, here you have your chemical and your organically or your bioclastic. Once again, you see that word down here. Okay, these are the ones that are formed chemically. So the crystalline ones are primarily going to be chemical. Okay, the bottom two can either be chemical or bioclastic. Okay, you see that here. Okay, and it's one thing, grain size. Once again, it's going to be fine grained, which is really, really small, all the way up to coarse grain. These are terms you should remember from igneous rocks. Okay, here's what they're made out of. Halite, you should recognize that one. Okay, we talked about those, right? The comments, crystals from chemical precipitates and evaporates. We'll talk about that in a minute. Okay, here's the names of the rocks. And there's the map symbols again. So once again, make sure that you know this chart. So you should have your reference table open. And as we go through these, you should be paying attention and marking it up. First grouping that we talked about are the clastic, or a fancy word that we sometimes use is detrital. Okay, these guys are formed because of an accumulation of material that originates and is transported as solid particles derived from mechanical and chemical weathering. What does that mean? It basically means that these rocks come from other rocks that get broken up and their pieces get carried by wind or water or ice and then pile up someplace else, get compacted, and get cemented down. Now, how do we tell one detrital rock, one clastic rock from another? We do it based on the size of the particles, okay? So we look at what the diameter of the particles is, and that's how we classify the types of rocks. In terms of what's inside of it mineral-wise, you're going to have mostly clays, feldspars, and micas. All this stuff is on your reference table. Now, the chart that you're looking at right now is going to be really important. Okay, this chart says the relationship of transported particle size to water velocity. Now, we're going to use that later when we talk about weathering, but it is important that you know the size of the particles that you're talking about. Okay, this chart is located right next to the rock cycle chart, right above the igneous rock chart, so you should have your reference table open to that. And if you look, this chart's got a couple of different things. On the y-axis, you have the particle diameter. That's what we care about. Okay, so if you're looking, the particle diameter gives you everything from 1/10,000th of a centimeter all the way up to 100 centimeters in size. Okay, and if you look, you see, now this one's color coded, yours isn't, but you see the dashed lines. So the dashed lines represent the cutoffs between the different sizes of particles. So clays are between 0.001 and 0.004. Silt particles are between 0.004 and 0.006. Sand is between 0.006 and 0.2. Pebbles are anything between 0.2 and I think this is 5.4. Sorry, it's a little blurry. And cobbles are 5.4 to 25.6, and anything bigger than 25.6 is considered a boulder. Now, you may get questions where these get thrown at you and they ask you to identify the type of particle or the type of sedimentary rock. You need to be able to use this chart to figure it out. So if you want to color code it like it is on screen, pause it now, snapshot the shot in, or if you want to color it in on your own, pause it so you can color it in as you see fit. But it's really important that you understand how to use this chart. All right, so the first sedimentary rock we're going to talk about is conglomerate. You see it at the top of the chart. You can see the map picture. It looks like it has pieces in it that are important. Well, conglomerate is made up of relatively large particles which have a size bigger than 2 millimeters. And the big important thing with it is that the particles in it are rounded. The reason that they're rounded is because the particles that are in conglomerate are primarily formed in rivers. And so water has a tendency to round things out. And so the pebbles and things like that that get put into this tend to be round in nature. Okay, so here's our sample of conglomerate. So if you look at this sample right here, you can see it's made up of lots and lots of different pieces all stuck together. You can see pebbles all over the place. But you can see how they're kind of smushed together by the smaller particles. And that's the big thing with conglomerate. It's a mixture of particles. Okay, so you've got round particles, you've got smooth particles. Okay, if you look here, you see none of these are nice, sharp edges. They're all smooth, and this is one of the things where touching it would actually help out, but you can feel the smoothness of this. Okay, so these guys can only be produced in rivers that are moving relatively fast, because you need to be moving relatively fast to carry particles that size. Okay, and so what ends up happening with conglomerate is the big pieces settle, and then the sand fills in the gaps between the two of them. It gets compacted, and eventually you end up with a particle that is a mixture of, or a rock, I should say, that is a mixture of all these different particle sizes. Make sense, guys? So the next clastic rock I'm going to talk about is breccia. It's the second one on the list. You see where it is right now. Breccia is made up of particles that are about the same size as conglomerate, but the difference is these are angular, which means they are pointy particles. They have sharp edges. Okay, you can see them in the picture here. Here you have a sample of breccia, and you can see these are nice sharp particles. They don't have that nice roundness that we just saw in the conglomerate that I was holding in my hands. Okay, now the thing about breccia is that breccia tends to form at the bottom of mountains. So you get a mountain, you get an avalanche, you get weathering that happens up there, and you get these piles called talus, T-A-L-U-S, talus slopes. Those talus slopes are built up of just these fractured, broken pieces. Think of breaking a dish. Okay, now slowly over time, get piles upon piles upon piles of these guys building up. Okay, and what ends up happening is you get a very similar thing that happened to conglomerate. The big pieces get cemented together with the smaller pieces, and eventually you end up with this rock that looks similar to conglomerate and can be tricky to tell the difference between the two of them, but it has sharp angular pieces, whereas the conglomerate does not. The next group of classic sedimentary rocks are what we call sandstones, and sandstones are made up of sand. Okay, you have the sizes on your chart right there. Now, sandstones are what we think of usually when we think of sedimentary rocks. In fact, the picture in the background that you've been looking at are sandstones. Now, sandstones have typically this layered appearance. Okay, they look like a layer cake, especially the really well-developed ones, like you can see in the images that you've seen on the screen. Okay, now sandstones, there's lots of different types. There's not one single type. Some of them have a lot more quartz, some of them a little bit more clay in it, but they are all primarily sand-based. Okay, in the picture that you're looking at right now, you can clearly see the nice divided layers. It looks like a petrified piece of birthday cake when you have the different layers in that birthday cake. Okay, that is what we think of when we see a sedimentary rock usually. Usually we're thinking about stuff like sandstones. All right, the next type of clastic rock is what we call siltstone. Siltstone is composed mostly of particles that are very small, what we call silt. Very small, you can't feel them individually, you can't see them individually, but you can feel them. Siltstone is usually formed at the bottom of lakes and ocean floors where the currents are not very much. It's very gentle. Because of that, siltstones actually make an excellent reservoir for fossils, particularly the fossils of soft-bodied creatures or things that don't have hard parts, like the leaves that you see in front of you. These leaves were actually fossilized in a layer of siltstone at the bottom of a lake, and you can see the particles are so fine that they can actually show you a heck of a lot of detail for these plants. There's no actual plant there, but what it did is kind of leave the impression of itself. The last group of classic sedimentary rocks that we're going to talk about are shales. Shales are fine grain, which means they're the smallest particles. They're made up of about 2/3 clay and about 1/3 silt particles. So they're really, really tiny particles. And one of the easiest ways to tell this guy apart is that shale has a tendency to split into kind of flat sheets. We call this property fissility. Okay, once again, shale is going to tend to form where you have very gentle ocean currents, almost nothing going on, and these tiny little particles can settle out. Okay, and so you can see the layers in this picture, the layers of what we call laminae, which are these layers that split up easily, and you can clearly see them in the picture of the actual shale in front of you. Alright guys, so I didn't get through everything in this video, but I should be able to get through everything else in about a 5 or 6 minute video, so go on to video 2. Alright guys.